paper of the day is Sort versus Hash Revisited. It's a 1994 paper. This paper has outlined many dualities between sort and hash-based query processing algorithms. Example, for intersection, join, and duplicate elimination. Under many circumstances, the cost differs by percentages rather than by factors, presuming that the algorithms have been implemented and tuned with similar care. They expected this result from the large number of dualities and verified it with the Volcano query processing system. Two special cases exist that favor one or the other, however. First, if the inputs of a binary operator are of very large different size, hash-based algorithms will outperform sort-based algorithms because only the smaller of the two inputs determines how many recursion levels are required or what fraction of the input files must be written to temporary disk files during partitioning, whereas each file determines its own disk I/O in sorting. Second, if the hash value distribution is not uniform, hash partitioning performs very poorly and creates significantly higher costs than sort-based methods do. If the quality of the hash function cannot be predicted or improved dynamically, sort-based query processing systems or algorithms are superior because they are less vulnerable to data distributions. Let's look at the experiments. The testbed for the experiments was the Volcano Extensible and Parallel Query Processing Engine. The purpose of the Volcano project is to provide efficient, extensible tools for query and request processing in novel application domains, particularly in object-oriented and scientific database systems, and for experimental database performance research. Let's look at the contributions. This article compares sort and hash-based algorithms and argues contrary to current wisdom as follows. First, many dualities exist between the two types of algorithms. Their cost differs mostly by percentages rather than factors. Many special cases exist that favor one or the other choice. And fourth, there's a strong reason why both hash and sort-based algorithms should be available in a query processing system. Continuing the contributions, the important conclusion from this research is that neither the input size nor the memory size determines the choice between sort and hash-based query processing algorithms. Instead, the choice should be governed by the relative sizes of the two inputs into binary operators, by the danger of non-uniform hash value distributions, and by the opportunities to exploit interesting orderings. Furthermore, because neither algorithm type outperforms the other in all situations, and because realistic situations exist that favor one or the other, both should be available in query execution engine for a choice to be made in each case by the query optimizer. Coming to PS score. Overall, this paper is a nice and engaging read, so it gets 9 out of 10 on readability. With 11 pages long, it scores 9 out of 10 on length. It's a measurement paper with decent description, so that makes it 9 out of 10. Its industry value and learning meter is pretty good, so it gets 8 out of 10 each. Overall PS score is 9 out of 10.